Yes, hello students. In my last lecture we have seen how to calculate the confidence interval and confidence limit. Now in this lecture we will be seeing the criteria for the rejection of result. So there are two empirical rules. That is 2.5D rule and 4D rule for rejection of data. Apart from that, there is also a test called Qtest. Now these two don't have their statistical basis. But this has statistical basis. And it was used by Dean and Dixon. And see, it has only one demerit, that when the deviation is small, it cannot give any result to the you can say it cannot give the rejection to the result. Whereas now see here, otherwise if the deviation is large, it is fine. Now see 2.5D rule. So what does it say? First of all, find the mean discarding the doubtful observation. Discarding doubtful observation. Then using the this mean, you can calculate the average deviation. All right. Then find the difference between the mean and the doubtful observation. Deviation of mean from doubtful observation. If this difference from mean is equal to or greater than 2.5 of average deviation, then the observation is to be rejected. Otherwise it has to be retained. Now see once again, find the mean discarding the doubtful observation. Then what you have to do is, using that mean, you have to calculate average deviation. From that then from using that mean, you have to find the deviation from doubtful observation. If the deviation from doubtful observation is equal to or greater than 2.5 times of the average deviation, then the observation has to be rejected. Now similar type of rule is 4.4D rule. All the three are similar, only here the difference is if the deviation from the if the deviation of doubtful observation from mean is greater than or equal to 4.0 of average deviation, then the observation would be rejected. So these are the two rules on the basis of which we can reject the data or retain the data. Now there is a test called Qtest. In Qtest, we have to first arrange your observations in the ascending order, then find the range, then find the difference between the doubtful observation to its nearest neighbor, and then this difference is to be divided by your range, and that is called as Q calculated. See, first of all, arrange in ascending order. In ascending order. Then second thing what we have to do is we have to find the range. Then third is find the difference of doubtful observation from its nearest neighbor. Then fourth step, you have to find Q calculated, which is called as rejection quotient, which is equal to the difference which you have found out. Say difference between the doubtful observation and its nearest neighbor upon range. If this Q calculated is greater than Q tabulated, then observation is to be rejected. Alright, otherwise it can be retained. So by solving the example, you can come to the conclusion. Alright. Now we will solve the numerical based on criteria for rejection of data and criteria Qtest 2.5D test and 4D rule, all those things. Alright. So now see a numerical. Listen carefully. Estimation of glucose in a sample of blood gave the following result. Can the value 101 be accepted or rejected on the basis of 2.5D, 4D and Qtest? Now the data is this way. See, 101, then you have 105 two times, then we have 106 once and 108 twice. Our doubtful is this one. Alright, and Q tabulated is given as 0.56. Alright. Now see, on the basis of Qtest first we have to do. So we have already arranged this in an ascending order. Now we have to find the range. Range will be equal to 108 minus 101. So it will be 7. Then find the difference between the nearest neighbor and the doubtful observation. Difference we have to find. So nearest neighbor is 105. So 105 minus 101, it comes out to be 4. Then we have to find Q calculated, which will be equal to 4 by 7, which comes out to be 0.5714. Now see, Q calculated is greater than Q tabulated. Alright, so rejected. Alright. Now next is on the basis of 2.5D rule we have to see. So first of all you have to find the mean. So sum this up and divide by 6. You don't have to consider this. Only these 5 you have to consider and divide by 5. So the mean comes out to be 106.4. Alright. Now we have to calculate the average deviation. So this is your x bar now. Sorry, yes, 106.4. xi minus x bar we have to calculate for each reading. So it comes out to be 1.4, 1.4, 0.4, 1.6 and 1.6. Alright, now summation of xi minus x bar, this is equal to 6.4. So d bar, that is deviation, 0.64 divided by 5. Sorry, 6.4 divided by 5. So it comes out to be 1.28. Now see, d questionable we have to find. D questionable is what? xi minus x bar, means your doubtful minus this mean. So it comes out to be minus 5.4. Now this is your average, D average. So D average, 2.5 D average will be equal to 2.5 into 1.28, which comes out to be 3.2. So here 2.5 D average is less than D questionable, hence rejected. Now see, for 4D average will be equal to 4 into 1.28. So it comes out to be 5.12. So 4D average is also less than D questionable, hence it has to be rejected. Alright. Now next sum we will see based on Qtest only. In an analysis of sample for its arsenic content, the following values were reported. There are 4 values they were reported. On the basis of Qtest, find whether the value 4.9 is doubtful value. This can be rejected or retained. Q tabulated is given to us. It is 0.76. Now see, the data which is given, I will directly write in an ascending order. 4.5, 4.6, 4.7 and 4.9. So now the range comes out to be 4.9 minus 4.5, it is 0.4. Then difference between the doubtful observation and the nearest neighbor. So that difference is doubtful observation and nearest neighbor. So 4.9 minus 4.7. So it comes out to be 0.2. So Q calculated will be equal to 0.2 divided by 0.4, which is equal to 0.5. So Q calculated is greater than, sorry, less than Q tabulated, hence the value is to be retained. Alright. So this is all about the rejection of data and 2.5D rule, 4D rule and Qtest. In the next lecture, we will be seeing testing the validity of hypothesis, that is testing the significance, null hypothesis we will see. Thank you.